Let's take a look at a radical function. Let's try doing the function f of x is equal to the square root of x. And so we'll put replacement values for x, and then we'll graph that and see what a radical function looks like. So let's start with the f of 0. So what is the square root of 0? So if I put 0 in for x, what is the square root of 0? The square root of 0 is 0. So I know I have a point here right at the origin. So my function of f of x is equal to radical x will include the point 0, 0. So let's try some other replacement values. 2, 4, let's see, 8, 9. Okay, so let's look for then the f of 1, right? So the square root of 1, if this equals 0, then the square root of 1 is 1. So then I know I have a point at 1, 1, so I'll put another point there. Let's try the f of 2. The f of 2 is the square root of 2. Basically, I'm replacing whatever my f of is with my x. And I know, let's see, well, the square root of 4, f of 4, the square root of 4 is 2 exactly. So this is going to be less than 2. Actually, it's a little more than 1. It's like 1.4 something something. So we're going to go ahead and approximate this at 2. We'll approximate that to be somewhere not quite in the middle. Then we skipped 3, and we went right to 4, but that one we knew for sure was right on the money there, because the square root of 4 is 2. So this is about 1.4, so this is 2. Let's see, we need to do the f of 8, which is the square root of 8. Well, I don't really know what that is, but I know that the f of 9, or the square root of 9, that's our next perfect square. So it's going to be 3. So if I go, let's see, that's 4, 5, 6, 7, 8, 9. 1, 2, 3. I know that that's there. And basically, what I'm describing is not a line. Well, that's yellow, it's going to be hard to see. Not a line. Let's do it in orange. But a curve that kind of, and again, I don't have the best drawing ability, but the curve kind of curves up a little bit slow, and then is just going to increase as we move along the x-axis. So the function of a radical expression looks like this curve here. Notice that we can't really do a negative x input value, because then we would have the f of negative 1, which would be the square root of negative 1, and this is not a real number. We've already stated, and we'll learn how to deal with this in a little bit. But as you can see, the important thing to understand is that I can't take the f of a negative number if my function is the square root of x, because I can't take the square root of a negative number. So my function's not going to come down here. It's not going to mirror off the way it might. It's not going to mirror off the way that it might look like a parabola. So this is a graph of a radical function. We can change that function around if we did something like g of x, say, is equal to the square root of 3x minus 2. Then our graph would look a little bit different, but it would not want to go down below into the negative areas. It will graph something like, it's going to shift it this way by about 2/3. Let's do that in a different color. Shift it this way by about 2/3, and basically curve that out. Basically be the same graph. So the function of the radical expression looks like a sideways curve. In fact, it looks about, well, we'll get into this function here being the inverse of a different kind of function called if f of x were, say, x squared, the inverse of that function would be the square root of x. And we're going to get into how these two are related in a very short time, actually.